Hi and assalamualaikum to everyone. My name is Nur Masrina Amalia binti Malizan. My matric number is 20139285. I'm from Year 1 UR 65230008. Today I want to present about mini project, which is my part is design and analysis of pi-type impedance matching network. First is introduction. The term impedance matching is rather straightforward. It simplifies, defined as the process of making one impedance look like another. Frequently, it becomes necessary to match a load impedance to the source or internal impedance of a driving source. A wide variety of components and circuits can be used for impedance matching. This series summarizes the most common impedance matching technique. Second is methodology. The circuit used to study and analyze a graph view. As you can see, this is the circuit of pi network, which is you set the value of V1, 1 VP, and then 60 megahertz. After that, RG is 1000 ohms and L total is 449.08 nanohertz, and then C1 19.91 picofarad, and then C2 57.69 picofarad, and then the last one is RL. The value of RL is 100 ohm. First, you set up the simulation. The step of set up the simulation is go to the menu simulate, and then you choose the analysis and simulation. After that, you can be at the active analysis, and then you pick the single frequency AC. After that, you can enter the value as you can see the figure A. Here I choose the frequency 60 megahertz. Or you can just click auto set. After that, at the figure B, as you can see the figure B, I just pick 3. I just pick 3 output as I want shown in the graph. Here the result of single frequency AC analysis that I do before. Here the pi network single frequency AC analysis, which is variable, real and imaginary. As you can see the figure. Here the second simulation that I did, same with the first simulation, which is go to menu simulate, and then you choose analysis and simulation. After that, you can be active analysis, and then you choose AC sweep. After that, you enter the values that you can see in figure C and figure D. After that, you run the simulation that you want obtain the first graph, which is magnitude and phase degree. On the graph tab, you just double click on the y-axis and rename it. After that, by using cursor, note the value of magnitude and phase degree. And then you just capture the waveform and tabulate the result. Here the graph output of AC sweep, as you can see, first is magnitude and below is phase degree. Phase degree is the graph of pi network, as you can see. Circuit analysis. The pi network matching circuit is used mostly in high to low impedance transformations. Figure 1A is the low pass circuit, and the figure 1b is the high pass circuit, and the figure 1c is the 2 back to L network with virtual impedance between them. Here the Pi network. The basic Pi network's primary application is to match a high impedance source to lower value to load impedance. It can also be used in reverse to match a low impedance to the higher impedance. The low pass version in figure 1a is a most common configuration, to the high pass version in figure 1b also can be used. You may design a P network using L network procedure. The P network can be considered as two L networks back to back. To use the L network procedures, you need to assume an intermediate visual load or source resistance RV as shown in figure 1c. Here the result that I have. As you can see, this is the table of comparison between theoretical and simulation that I did. The frequency of theoretical result is 60 MHz and the simulation result is 60 MHz. It's same. And then source reactance of theoretical result is 1000 ohm and the simulate is 1000 ohm. It's also same. And then load resistance RL of theoretical result is 100 ohm and then simulate is 100 ohm. It's also same. The Q factor of theoretical result is 75 and the simulate is also 75. The inductance or L total of theoretical result is 449.08 nanohertz and then the simulate result is 448.2 nanohertz. Here the source capacitance or C1 of theoretical result is 19.91 picofarad and the simulate is 19.894 picofarad. The load capacitance or C2 of theoretical result is 57.69 picofarad and the simulation result is 57.66 picofarad. My discussion is there are some important items to understand when using this tool. The circuit topology can change depending on the input. For example, in some topology, there may be two inductor and one capacitor, and in the different configuration, it may be two capacitor or one inductor. There is one menu item to select if there is to be any DC current or not. That also affects topology. The input asks for source resistance and source reactance. It is unsure what the reactance is set it to 0 for a first pass approximation. The output of this tool gives the component value as well as a graph of the impedance looking into the pi circuit from the source. This allows me to double check the calculator and make sure that it select approach values. By making sure impedance correctly match an input impedance, also remember that the circuit input reactance will be opposite in polarity with the source reactance when matching. Here, the conclusion of Pi network. In conclusion, this mini project is the Pi matching network is very useful for matching high impedance source to 50 loads. Pi matching is normally used in valve amplifier for high power solid state device. The impedance value become impractical with very large capacitors and very small inductors being required. The pi mesh circuit also get its name because the circuit topology can look like a pi symbol. This tool will create a matching circuit so that optical power transfer occurs between unmatched loads. This technique doesn't work for wide end requirements, but it is a simple way to achieve this at specific frequency. That's all from me. Thank you for watching.